All right, this video is for part 3 of your test review. This portion of the review will make up 15% of your unit test. Okay, so these are the harder questions. If you're struggling with the basics, stick with the basics, try these, but you need to make sure you can understand parts 1 and 2 before you worry at all about these harder questions. So this video is for questions 1, 2, and 3. For any value of x, the sum from 0 to 3 of k times 2x minus 1 is equivalent to which one? Now this one, if I look at my answers, I have x in every answer. So I'm not worried about getting rid of the x. Here's what I would do. If I have a sum, I'm going to list out every term in the sequence and then add them up. All right, my terms are going to have x's in them, and that's okay. So let's see. If I'm going to start at k equals 0, look at that lower index here. For k equals 0, I'm going to put 0 in for this k. So I will have 0 times 2x minus 1. And when you simplify that, that just equals 0. That's simple. Okay, I'm going to look at the second term now for k equals 1. I'm going to put 1 in for this k. So I'll have 1 times 2x minus 1. When I distribute, that gives me 2x minus 1. And that's the second term. So first term is 0, second term is 2x minus 1. Let's do k equals 2. So put 2 in here. 2 times 2x minus 1 will give me 4x minus 2. And finally, k equals 3. So that's 3 times 2x minus 1 will be 6x minus 3. Now I'm going to add up all of those terms. Term 1, 2, 3, and 4 to get me the answer. Hopefully it's one of the ones we have on our multiple choice. So I add up the x's. 6x plus 4x plus 2x is 12x. 0, negative 1, that we, minus 2 is negative 3, minus 3 is negative 6, and I see that is answer C. Looks complicated, not as bad once you understand what you're doing. All right, number 2, another multiple choice. If the following is a geometric series, coordinate, which of the following is its value? All right, so the first thing we have here is a geometric series. I want to know the value. That means I'm going to sum things up. Now what I'm going to do is I'm going to use sigma. You don't have to use sigma. You can use the S sub n formula. But I'm going to use sigma because I think it's going to make it a little bit faster to find the sum at the end. So I need sigma, and then after sigma, I have to put my A sub n formula here for geometric. So I'm going to fill out what I know. I have the first term, which is 5. My common ratio, it looks like I'm multiplying by 3 each time, to the n minus 1 power. Okay, so I know the first index, I'm assuming, is n equals 1, right? I'm assuming term 5 is the first one. And I know the last term is 98,415, but I don't know what the index is for that term. What is the n for that term? So unfortunately, I have to do a little bit of work before I can just type things into the sum. And I'm going to have to find the value of n. What I will use is the formula in pink up here, A sub n. So I'm going to put in for A sub n, I know that term is 98,415 equal to the first term times 3 to the n minus 1. And I'm going to solve that for n. So I'll start by dividing by 5. And that answer when you divide by 5 is 19,683 equals 3 to the n minus 1. And you have to use your favorite thing. You have to use a logarithm here to get that n out of the exponent. So I'm going to take the log of both sides. And you have to divide by the log first before you deal with the n minus 1. So because I'm solving for n, and n is going to be an integer because we're solving, n is only a counting number because it's a term number, I can divide the logs to start. So log of 19,683 divided by log of 3 gives me the n of 9. So n here, so I have 9 equals n minus 1. If I add 1, I get n equals 10. Now that's helpful because that tells me that this term, 98,000, is A sub 10. That's the index of 10. And now I can type this sigma into my calculator to find the sum. So I'll go math 0, index from 1 to 10, and then my formula, 5 times 3 to the x minus 1 power. Then I get 147,620, which is option B. There you go. All right, one more for this video. Find the sum of the series. Show all work. So that means you can use sigma, you can use an S sub n formula, whatever works for you. We have to figure out what type of series it is. So I have -2 to 10 to 22. That looks like I'm adding 12, is what I'm thinking here. So it looks like arithmetic. So I'm going to be not using geometric. So I'm going to use these guys over here. So let's see. Find the sum of the series. Sorry. Let's see if we can use sigma here. So if I use sigma, I have to come up with the a sub n formula to go right here. So I have to do a little bit of work. I'll have a sub n equals my first term plus 12 times n minus 1. And I'm going to simplify that. So I'll get -2 plus 12n minus 12 is 12n minus 14. All right, so that's going to go right here. Now, just like the last problem, number 2, I know that the first index is 1. That's what -2 is. That's a sub 1. I do not know what the n is for 226. So what I need to do is put that 226 equal to the formula. And I'm going to take 226 equals 12n minus 14, because that formula is the formula for the sequence. And if I solve that, it'll find me the value of n. So I'm going to add 14 to both sides. So you'll have 226 plus 14, that's 240. And then when I divide by 2, I get 20 as my n. So I can put that 20 as the index. And now it's just like the last problem. I type that into my calculator, and it'll tell me the sum. So math 0, we're indexing from 1 to 20 of, what did we say the formula was? I forgot already. 12n minus 14. And you get 2240. Now you could do the exact same thing using the S sub n formula. I think actually on my key, if you check on Canvas, my key actually has me using the S sub n formula. Both of them work. It doesn't matter either way. Okay. So that's the end of this video. There's two more for part 3.